Okay, so in this video here, we're going to be talking about simplifying down radicals. So before we can do this video, we have to understand what a radical is and the different parts of a radical. So I have this diagram here, and you can see that there's 3 different parts to a radical. I have my index, and that's going to be this value right here. And we're just calling that n for now. Okay, so we have an index. Then we have our radical, which is the check mark looking thing. And underneath the radical, we have the radicand. Okay, that's our actual value. So the thing that you have to understand here is that a square root is a radical. Okay, it's a type of radical. And a square root will always have an index of 2. Now, they may not write it. So for example, if I have the square root of 4, okay, this actually has an index of 2. They don't write it, but it's actually there. So you could actually write this as an index of 2 if you really wanted to. It's just one of those things where if it's a square root, they're not going to include the index, but it will be 2. Now, if you had like a cube root, well, that would be this here, right? The cube root of 4, or you could have the 4th root of 4, right? And so on. So all the other radicals, you are going to be including the index, but the square root is the only one that you don't have to include it. So just keep that in mind, all right? So now that you know the different parts of a radical, let's go ahead and try some of these problems. Okay, so here's our first example, and let's kind of go over some basic parts here. I'm dealing with a square root, meaning I have an index of 2. So when I start breaking this thing down, I'm looking for a pair of values that I can pull out. So in other words, in order to pull something out of this square root, I need 2 of the same thing. Okay, that's what the index tells you. I need 2 of the same thing in order to pull it out. Okay, if this was a cubed root, so again, if it was like the cubed root of 192, that's telling me that I need 3 of the same thing in order to pull it out. Or if I had a 4th root of 192, that means I need 4 of the same thing in order to pull it out. Okay, so the index tells you how many you need in order to pull it out from underneath that radical. Okay, so let's go ahead and talk about how we're going to do the problem now. So it's pretty straightforward. Let's go ahead and get rid of this stuff here. We're just going to do something called prime factorization. And essentially what you're doing is you're building a tree. I simply do 2 legs, and I come up with 2 numbers that when I multiply will give me 192. It could be any 2 numbers, just don't do 192 times 1, okay? So anything other than 1 will work here. So I know that 4 times 48 will give me 192. That's good. And then you want to keep breaking down these values until you finally reach the prime factors. Okay, so for example, 4, I can break that down to 2 and 2. Again, don't do 4 and 1, right? But you'd break it down to 2 and 2. Now these are prime. 2 is prime, 2 is prime. I'm good. There's nothing else I can do here. Okay, so now I'm going to move on to the next value. I have 48. Well, I could break that down using 6 and 8. And then looking at 6, I could do 3 and 2. And now these are prime. 3 and 2 are prime. I'm done. I don't have to keep going. On 8, I could do 4 and 2. Okay, this 2 is prime, and I can keep going with the 4, 2 and 2. So now I have it down to its prime factors. And so from here, you can check your work. If I multiply all of the prime factors, I should get 192. Okay, so if I were to multiply all of these prime factors, I should get 192. You can check your work that way. But we're going to go ahead and skip that step. All we want to do is try to simplify this down. So start looking for pairs. Remember, I need 2 of the same thing. So let me go ahead and get rid of this stuff here. I see that I have a pair of prime factors right here. Okay, so I can pull out a 2. And then I have 2 more right here. And then I even have 2 more right here. You can see that, right? So I can actually pull out 3 2s. So for example, I'm going to pull out 3 2s, and it's going to be 2 times 2 times 2. There's 3 of them. 1, 2, 3, right? What stays underneath the radical? Well, in this case here, it's going to be my last prime factor that I have, which is 3, right? I didn't have a pair for that. So that 3 stays underneath. Okay, and now we just do the operation. 2 times 2 times 2 is going to give you 8. So I'm left with 8 square root of 3. There it is. It's simplified down. So to be clear, if you were to do 8 square root of 3 in your calculator, and you were to do the square root of 192 in your calculator, you are going to get the same exact value. But 8 square root of 3 is going to be simplified down. Okay, so let's go ahead and try another example. Okay, so here's our next example, and now that we know what we're doing, we're just going to go for it. So our index here is 2. Remember, it's a square root. They don't have to write it, but we'll go ahead and write it in there. And we just have to come up with 2 numbers that when I multiply will give me 45. So we can use 9 and 5 here. Now look, 5 is prime. I can't go any further, right? So we're going to leave that 5 there. But the 9, I can keep going, right? 3 and 3, okay? So now I have it down to its prime factors. I have a pair right here, meaning I can pull out those 3's, and the 5 is going to stay underneath that radical. So our final answer is going to be 3 square root of 5. Done. Okay? All right, let's try another example. So here's our next example. Again, another square root. I'm going to go ahead and put in the index of 2. Now, don't freak out here. You do have a variable, but we're going to save that for the end. We're just going to work on that coefficient in front, 72. Okay, then we'll worry about that variable. So again, let's do 72. Well, I can use 8 and 9 here. Okay, that will work. Breaking this down, I get 3 and 3. Okay, that's done. Right here, I can do 4 and 2, and then I get 2 and 2. All right, so I'm going to go ahead and circle my pairs. Right here, I can pull out a 2. I can pull out a 3. And this prime factor is going to stay underneath the radical, okay? So I'm pulling out a 2 times I'm pulling out a 3. Underneath the radical, I still have 2. And we do have to take care of this variable now. Now, the variable is super easy, okay? What's really going on here? It's really x times x times x to get that x cubed, right? So I have an index of 2. I can see that right here, right? Meaning I need 2 of the same thing to pull it out. Well, I have 2 right here, okay? So I can pull out an x, and this x will stay underneath. So finally, it's going to be 2 times 3 times x, and then the square root of 2, and then x. And so our final answer here is going to be 6x square root of 2x. Done. Okay, that's simplified down. All right, so let's go ahead and try some more examples. So here's our next example. Let's go ahead and just go for it. Again, we do have another variable here. We'll save that for the end. And I do have an index of 2. I'll go ahead and write that in. So I need 2 numbers when I multiply will give me 128. So I can use 4 and 32 here. And this will break down to 2 and 2. This will be 8 and 4. I can keep going here. 2 and 2, 4 and 2, and then 2 and 2, okay? So let's go ahead and circle our pairs. I have 1 here, 1 here, 1 here, and this 2, I don't have 1 for, so that 2 stays underneath. So I can pull out 3 2's. So 2 times 2 times 2, there's 3. Underneath, I'm going to have 2. That one's staying there. And now let's take a look at our variable. Again, that's really x times x times x times x. My index is 2, so I have a pair here, and I also have a pair here. So I can pull out 2 x's. So putting it all together, I'll end up with 2 times 2 times 2. That will give me 8. And now remember, I'm pulling out 2 x's, so x times x will give me x squared. So I have x squared here, and then the square root of 2. Okay, done. That's our final answer right here. All right, completely simplified down. All right, let's go ahead and try 3 more problems. Okay, so here's our next problem, and notice we're not dealing with a square root anymore, we're dealing with a 4th root. But it's pretty much the same thing. Remember, the index is telling us how many we need of something in order to pull it out. So for example, in this one here, I need 4 of the same thing in order to pull it out. So let's go ahead and break this down into its prime factors and see what we get. Well, 16, that's easy, 4 and 4. And here I get 2 and 2. 2 and 2. Look how that one works out, right? Look, I have 4 2's right here. These are the prime factors, meaning I can pull out 1, 2, and I have nothing left underneath that radical. I'm done. My answer here is going to be 2. That's simplified down. So the 4th root of 16 is going to be 2. All right, let's try another one. Okay, so here's the next problem. Looks complicated, but it's really not, right? We have an index of 6, meaning I need 6 of the same thing in order to pull it out. So let's work on our coefficient first, 729, and then we'll work on this variable here, okay? So breaking this down into its prime factors, I need two numbers when I multiply that will give me 729. And I can actually use here 9 and 81. Okay? Breaking my 9 down, I get 3 and 3. So that one was pretty easy. 81, I get 9 and 9. 3 and 3. And then 3 and 3. So remember, I need 6 of the same thing. So I have here 1, 2, 3, 4, 5, 6. That one worked out pretty nice. So I'm actually going to pull out a 3 here. So that's exactly what I'm going to do. I'm going to pull out a 3. Then what? Well, now I have to work on this variable. Remember, I'm multiplying x by itself 8 times. Okay? So I can pull out an x. How many are going to be left over? I'll have 2 x's left over, right? So I can pull out an x, but I'll have 2 x's left over because remember, it will be x to the 6th power times x to the 2nd power, which is really x to the 8th power. So I can pull this one out, that's what I'm doing, and this one will stay underneath, okay? So just going back over here, I'll have the 6th root of x squared. Okay, and that's done. So this right here would be my final answer. Okay, let's try one more example. So here's our last example, and we're dealing with a cubed root here. I can see the index right here, or third root, however you want to say it. So let's go ahead and work on the coefficient. So I have 48. So two numbers I could use here are 8 and 6. This will break down to 4 and 2, 2 and 2. And this one here will be 3 and 2. So I need 3 of the same thing. So I have that right here. These 2's, right? So I can pull out a 2, and what stays underneath? Well, these prime factors right here, 2 and 3. And so I can pull out a 2, so I'm going to do that. So I have 2. And then we said that 2 and 3 are going to stay underneath, but that's really 2 times 3, so that will give us 6. So I'm going to have the cubed root of 6, okay? And now we can work on our variable right here. So remember, I need 3 of the same thing. I could really rewrite this as x cubed times x. That's the same thing as x to the 4th power. So I can pull this one out. This is going to stay underneath. Let's go ahead and finish this one off now. So I'll have 2, and then I said I can pull out an x, and then I'll have the cubed root of 6, and then x. Done. This right here would be my final answer. Okay? So that is simplifying down radicals, all right? It's pretty straightforward. Just remember, look at the index of the radical. That's going to give away the information of how many you need of something in order to pull it out. And remember, if you're dealing with a square root, they're not going to write in the index, but it does have an index of 2. So just keep that in mind. So I hope that you gained something from this video. I hope that it helped you. If so, if you could just go ahead and give it a thumbs up, that would be greatly appreciated. Also, make sure you subscribe to this channel so you get more math videos in the future, and I'll see you in the next one.